All right. So we've got kind of the basics for fractions set up, right? In general, right? So these are numbers that are sort of less than one whole, and we're sort of defining them, right, based on the denominator, how many pieces make up a whole, and then our numerator tells us how many of those pieces we have. So what that kind of means for us is, in some sense, what we would call a proper fraction. Would be a over b, where our value for a is less than the value for b. I'm using absolute values here in theory, right? The a and b could be positive or negative. So you have a smaller number on top and you have a larger number on the bottom. That's kind of what people generally just think of as a fraction, just kind of by itself. And so that's technically what we would maybe call a proper fraction, which would lead us then to sort of ask, probably, if that's a proper fraction, what the heck is an improper fraction? And an improper fraction is going to be the same setup, except the value on top is going to be larger than the value on the bottom. So you're going to have a bigger value on top than your denominator. Your numerator is bigger. So if you're, taking something like, right, maybe you're in fourths, but instead of having 3/4 or 1/4 or 2/4, what you have instead are 9/4, right? So you're broken up into fourths, but you have more than 4 out of 4. You're actually going to be, in this case, larger than 1. You're going to be larger than one whole. But you're not necessarily going to be a whole number, right? So you're talking about a value, you end up with something that kind of is in between two other whole numbers, but it's going to be larger than 1. A lot of times, just like out in the world, when people say fractions, right, you say like, oh, this is, such and such, the same product, but it's a fraction of the cost. People say fractions usually when they mean just like something that's less than, something that's like a part of. But fractions for us just mean any kind of numbers that are sort of in between the whole numbers. So you could have an improper fraction, which is a fraction still, but it's actually going to be larger than 1. Somebody could do a really horrible advertising routine and say something was a fraction of the cost when it actually was more expensive, 1.5 times as expensive or something. That would be a really dumb and mean math joke. It wouldn't even really be a joke. It just would be a good way to lose business, I guess. So something like 9/4, right? Something like 11/6, right? Like 15/3 or whatever, right? Any of these kind of things. You could do negatives also, right? Negative 28/5, right? Any of these things would be improper fractions. You sort of have a bigger value on top than you have on the bottom. So, okay, what the heck can we do with those? Well, I mean, in some sense, you can just leave them, and sometimes you're going to need to leave them, or you're actually going to need to have your values in that form to be able to sort of do good math things with them. But if you have an improper fraction, you can convert it into what we call a mixed number. And so a mixed number is essentially a combination of a whole number and a fraction. So a mixed number will look like it would look like something like A and then like B over C. So what you have is a whole number out in front, right? That's kind of larger, and then we still have our sort of classic fraction, numerator, and denominator. And the numerator and the denominator work and sort of mean exactly the same things that they mean before. They sort of work in the same way, right? You sort of have a whole value broken up into however many pieces is your denominator, and then b, your numerator value, is however many of those pieces you have. You just have, in addition, right, some whole number out in front. So you have, right, something like 6 and 2/5, right? Or you have something like, negative 4 and 3/4, right? So it's a whole value and then an extra fraction portion, right? A whole value and then a sort of extra fraction portion. So the question here for us is, okay, so if I have a fraction value that's larger than 1, I have sort of two ways to write it. I can write it either sort of as an improper fraction and just sort of leave it in sort of a pure fraction form and just have a bigger numerator value. That's going to be useful to do other fraction math with it. You're going to kind of need that form to do things like multiply and divide. But in terms of just like how big is this number, something like 6 and 2/5 is maybe a little bit easier form to just sort of conceptualize, right? I've got 6 whole pizzas, and then I have 2/5 of another pizza, right? So having a number written as a mixed number helps you see a little bit better what the size is. If you think of like, measuring stuff with a ruler, right? Rulers, right? You have sort of inches, quarter inches, half inches, right? Eighths of an inch. You have these kind of things. So you would probably say, right, if you're measuring something, you'd say I have, 3 1/4 inches is sort of how you would say it and probably how you would write it. You wouldn't necessarily say that you have 13 1/4 inches, even though that is what you would have. 3 1/4 inch would sort of sync up with 13 quarters of an inch. But like if you say I have 13 1/4 inches, that's true, but it's also a little bit tough to kind of mentally figure out, well, how the heck long is that? Is that 3? Is it 5? Like what's even the ballpark that we're in? So what we need to do just sort of briefly is talk about converting between these two forms. So let's go first from an improper fraction to a mixed number. And so essentially what we're going to do is we're going to use long division. But for the most part, right, our numbers here are not gigantic, large numbers. So, long division here, long is a pretty relative term. This division shouldn't take super long. And essentially what we're going to need is, this long division to find our remainders. The remainders are going to turn into our new numerators. Let's just sort of run an example, and I'll sort of take us through the steps. I'll recycle one of our ones from up here. Let's start with this like 9/4. So let's do 9/4 into a mixed number. So my setup is going to be, so this is 9 divided by 4, right? So if we think of this fraction, any of these fractions, treating it almost like a division, right? Treating the fraction bar like a division bar. So 9 divided by 4, that's going to be 9 on the inside, and you're dividing it by 4 on the outside. And so whenever we're doing long division, right, our sort of denominator values are going to go out here. We're dividing into the 9, right? So this is 9 divided by 4. 9 divided by 4. So the steps, right, we're just going to say, okay, so how many 4s divide into 9? How many 4s can I fit into 9? Well, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. 12 is too big, so I'll go with 2. So I can fit 2 holes in there. 2 times 4 would get me 8, and if I subtract away, I'm going to be left with my remainder 1. 1 is not big enough to fit another 4 into, right? It's obviously less than 4. So what my result is going to be, right? So 4 dividing into 9, I get 2 whole values, and then I get 1 remainder. So out of my denominator 4. So what happens here is my remainder ends up in the numerator position. The denominator stays the same. And then my whole values, right? How many whole 4s can I fit into the 9? The whole values here end up in front. So 9 over 4 becomes 2 1/4. Just like that. Let's run a second example. Let's do this 28 over 5 maybe. So let's convert negative 28 over 5 to a mixed number. Okay. So I'm essentially going to ignore the negative. The final answer will still be negative, but like as far as actually doing the division, it doesn't matter if I have a negative or a positive. The steps will be the same. So I'm just going to set up, right, 28 divide by 5. So that's right 5 going into 28. Doesn't matter, right? Positive, negative. We're just going to leave it. Our final answer will still be a negative, right? And sort of that will be that. 5 into 2 doesn't fit. 5 into 28 would go 5 times, right? 5 times 5 would be 25. If I subtract away, I'm going to get my remainder, which is 3. We're not doing kind of decimal stuff. We'll do those in chapter 5, right? We're not going to put on a 0.0 and keep going or anything like that. The idea is just to get it down to the whole numbers and stop. Excuse me. So what we've got is 5 as the whole value, and then my remainder is 3 out of my denominator that was 5. Right? The original was negative, so my final here is also going to be negative. You could do this. Let's take one more of those examples from the other page. We had 15 over 3. Sometimes what will happen is you do the division and you don't get a remainder. And if that happens, that's fine. That is kind of one less thing to worry about. You're just going to end up then with a whole number. So this is 3 dividing into 15, right? 15 divided by the 3. 3 doesn't go into 1, but it goes into 15 5 times, and 3 times 15 hits right on the nose. So our remainder here is 0. So what that means for my result is I'm just going to get whole number 5. I mean, in theory, I guess then it's 0 over 3, but 0 over 3 is just 0, right? So what we're going to do is we're just going to call that 5, and we'll call it a day. So that's our conversion, converting, right? So this fraction value into a mixed number, or in this case, we end up with a whole number. We'll do another video here, and we'll do the conversions going the other direction. So if we started with a mixed number, we'll look at the conversion going into an improper fraction.